2.9 weighted average problems, and the topic that we want to focus on today is investment. Okay, before we start with that, I'd like to bring up a model. Perhaps you have heard of this before, but it's good to have a quick review here before we start our actual problem. Now remember this I equal PRT model. This is, you learned this probably in 7th grade, where we use this particular formula right here to find the interest. Imagine you put some money into the bank, and that bank offers you some interest rate, back at the end of the year. We call this simple interest. Okay, so just start out with something like this. Let's say you have $5,000, and you don't want to just leave it there and not get anything back, so you decided to put it into a bank. Now Citibank happened to offer a 2% interest for a CD account, like it's a saving account. Okay, CD offers 2% interest rate for a saving account, and you decide to go ahead and put it into that saving account. So how do you find the interest rate after a year? We'll make this simple by using what we call a simple interest annually. So that means you get back your interest after a year of leaving it in the bank. So the way that we do it is by taking your 5,000, which we call the principal, okay, or P for short, and the rate right here is 2%. Now don't forget, whenever you put this back into the equation, you got to convert this percent into a decimal. So the 2% now will becomes 0.02. Don't forget to divide it by 100, or when you divide something by 100, you move 2 places to the left, decimal 2 places to the left. Okay, so this is the actual value that we're going to be using when we calculate the percent. Now you need to convert the percent to decimal format before we start. So we have the rate, we have the principal balance, which is your initial amount where you put into the bank, $5,000, and T right here stands for time. In this case, I did say we're going to do simple interest for 1 year, so the time in this case will always be 1 year. Okay, it's going to be a 1, so we don't really care about it because 1 times anything is just a cell. So the way we solve for the interest, I stands for interest, is to take the principal balance, which is your initial amount, $5,000, times it by the rate, which is 2%, or when you put this into the equation, it's 0.02. The time, like I said, is constantly at 1 because we're doing it annually. It can change depending on how you want to do it, but for now, it's all about being annual. So it's just 1. So 5,000 times 200 will give you this much, don't forget. And of course, you need to move your 2 places back. Let's see, that's correct. Yeah, 2 places back, which means you're going to have $100 as your interest. 5,000 times 0.02 will give you 100. You can go and certainly check that. And this 100 right here would be your interest after 1 year. Okay, so now that you get an idea on how to find the interest, let's take a look at our actual problem. Here we go. So Matthew here had $4,000, and he wanted to go ahead and invest in this amount into not just one bank but 2 banks. So if you kind of read on, you see this. It says that part of this money will go into a 2% annual interest, and the rest at 5% annual interest. So you can kind of see right away that he wants to invest his money into 2 different banks. Okay, and at the end of the year, he will get a total interest from both banks at $125. So the question now is, how much money did he invest at each rate? It means in each bank. So the scenario, you can see you have 2 banks that he's going to put the money into. So what I suggest you to do for this problem is set up a table. I think it's best to organize it as a table. Okay, so let's do it this way. We have Bank A, Bank B. You can call it Bank A, whatever, or Bank of America, whatever you want to call it. And this is Bank B. And we are using the IPRT model, which is the one I just introduced earlier. And of course, the first column right here would be your principal, or your amount that you're going to invest in each bank, and this is your rate. Okay, and T right here would be your time that you can put it in, and because it's just for 1 year, you know it's going to be constant for both banks. Okay, and then the last column right here will be your interest. Okay, so you kind of see that we're just multiplying across here to find the interest. Now, if you read carefully, we certainly don't know how much he's going to put in Bank A, and we don't know how much he's put in Bank B either, right? So for that, I can just go ahead and declare a variable. Say, okay, in Bank A, I don't know how much he's going to put in it. Let's declare an X for it. For Bank B, I don't know how much he's going to put in it either. So let's put in a Y for it. Now, every time you declare a variable, don't forget to define it. So X would be amount invested in Bank A, and Y would be the amount invested in Bank B. Okay, so I'm clearly defining it so that once I'm done solving it for, I know exactly what X and Y's are. And the rate now, for Bank A, you can, well, in this case, since we approached 2% first, so I'm just going to go ahead and say Bank A investing this amount, and the percentage is 2%. Don't forget to put this back as a decimal. And for Bank B, it's 5%, so I'm going to go ahead and put that back as 0.05. And if I times it across, I know I'm going to get 0.02x, and this is going to be 0.05y, right? Because that's what the formula says. P times R times T equals to I. All right, so now that we have this column right here, let's focus on the principal column, and let's focus on the interest column, because, you know, that's what we need to focus on. Now, the principal is the amount you invest in both banks, right? And we know that he had only 4,000, so that means if you take the amount from both banks, which is X plus Y, don't you have exactly $4,000? Because this is the amount invested in each bank, and he had 4,000. For the interest now, well, if we know the 2% here times the amount invested will give you the interest. So this is the interest from Bank A. Notice I'm just going and adding down here, and I'm also getting the interest for Bank B. The total interest from both banks, which are already given, $125. So very similar to what we did with the dry and wet mixtures. And we got ourselves two equations. And from here, we can start using substitution method to solve for our variable. So let's say I want to solve for x here, so I subtract the y over. So 4,000 minus the y. So whatever x is, I just go ahead and substitute it into my x. Okay, now let's do a quick substitution here. I will have 0.02 times 4,000 minus y plus 0.05y equals to 125. Okay, so if you continue and distribute that, this will give you 4,000, 2% of that's just going to give you 80 minus 0.02y plus 0.05y equals to 125. And if you continue to solve this problem right here, I combine like terms, it's going to be 80 plus 0.03y, or 300y, equals to 125, minus 80 both sides. You end up with 0.03y equals to 45, right? And of course, if you hate, well, it doesn't really matter. Let's say I don't want to deal with decimal. You can certainly clear decimal at this point if you want, or in this case, just go ahead and divide it straight. Y equals to 45 divided by 0.03. Let's take care of that right now. So move 2 places over. So it's really 3 goes into 4 1 time, 5 times. So 0, 0, so 1,500 bucks. So y, which is, if you go back to the definition of y is 1,500, which is in bank B, and I want to find out what bank A is, so I just plug it back into this equation right here, which we already solved for. X is 4,000 minus y, which means 4,000 minus 1,500 ends up being 2,500. Okay, so your final answer would be, in bank A, I invested $2,500, and for bank B, Matthew invested, sorry, not I didn't invest it, I didn't invest, but Matthew did, 1,500 bucks. So that would be your final answer for that one. Okay, so I would expect you to use the same model for this next problem that I want you to work on. Let's quickly write this problem down, and I want you to go ahead and work on that. Okay, so one more example. Here's a different variation to the problem. I want to make sure you understand what's going on, but we are using the same model. So right here, Michelle has $12,000 to invest. She wants to put some in certificates and some in a saving account. So you can see it's pretty much the same, so you can certainly set up your table once again. Same format. So I'm going to have, in this case, it's a CD account, and the other one is a saving account. Okay, and I'm using the same model, P, R, T, interest. Okay, so here's the principal, here's the rate, here's the time, and here's the interest. Okay, so let's take a look. We don't know how much she puts into her CD account. We don't know how much she puts in her 3% of, which is the saving account either. So once again, X, we don't know how much she puts in for CD. We don't know how much she puts in for savings. So as soon as you declare it, define it. So X is the CD, Y is the saving. I'm trying to save me some time here, but that's what you need to declare. X is the amount in CD, Y is the amount in saving. And the rate for the CD, which is certificates of deposit, is 6%, so it's going to be 0.06. The saving account is 3%, so it's going to be 0.03. And once again, this is a simple interest problem, so annually it's just going to be 1 year. So if I multiply across, it's going to be 0.06x and 0.03y. So very similar. We're just going to once again focus on the principal column and the interest problem column. Okay. Now, if you read this problem very carefully once again, you notice that the total interest is not given for this problem. However, this is what's given. If she wishes to receive the same income from each account, same income. Well, we know that she had only $12,000 to invest, so that means the balance from the CD account and the saving account, which is X plus Y once again, which is the same, $12,000. Okay. Now for the interest, which takes on a different twist, the total interest is not given, but what we know from this problem is that she wants to have the same interest from both accounts. So that means the money she receives at the end of the year from the CD should be the same as the saving. And we know the word same means equal. So therefore, we can take the interest from the CD account, which is 0.06 times X, and the interest from the saving account right here, and equate them because we want them to be the same. And so this is how we obtain our second equation. And we can just do the same thing once again with the rest to solve for our X and Y using substitution method right here. We can just say solve for X once again. I would have 12,000 minus Y. And I just substitute that into my other X. So you would have 0.06 times 12,000 minus Y equals to 0.03 Y. Okay, so you can certainly distribute that. It's going to give you 6% of that. It's going to be $720. Okay, and this is going to be 0.06Y because 0.03Y. add it over. $720 equals 2.09y. And if we continue on with this problem right here, you know, I hate dealing with decimals, so let's multiply the whole thing by 100 to clear it. So what we will end up with is 2,000 equals to 9y. It makes it a lot easier for me. Divided by 9, so y would be, if you divide it, you have $8,000. Okay, so that means the amount invested in the saving accounts is $8,000, and we can certainly easily find the other account by taking 12,000 minus y based on the previous equation. And so that means your CD, which is x right here, 12,000 minus 8,000, which is $4,000. Okay, so we got x and y, so that means our CD account will receive $4,000, and our saving will receive $8,000. Okay, which end up being $12,000 that Michelle wanted to invest. Okay, all right. So with that in mind, now that you know how to do this, I want you to go ahead and try to have a simple problem. This is also from your worksheet as well. Let's take a look at that one, copy it. Well, you don't have to copy it down because it's already in your worksheet. So you can just go ahead and solve this problem, and that will help you finish one of your homework problems. Okay? All right.